What do I mean by positive and negative intervals? Well, if we had a line, just a line on a graph, and we had something like, maybe it was something like that, okay? Just very bumpy and all that, okay? As you can see, between any two zeros, the line is going to be always positive or always negative. Because if it were to go from negative to positive, then that would mean it had to cross another zero. So between zeros, the sign is always constant, okay? But how can we figure out if between two zeros it's a positive or negative interval? Well, what you basically do is you could just plug a value in between the two zeros into your equation. So let's look at this. Let's look at an equation like, how about x minus 3 times x plus 4 times x plus 2 times x plus 5, okay? And so if we were to plug this into an equation, if we were to plug any value into the equation, it would tell us for, okay, maybe we're going to plug in, I don't know, whatever value that is, maybe negative 1, it will output a negative value, okay? So we will know if we plug in an x value between two zeros and it comes out with a negative number, we know that that whole interval will be negative, okay? So first, let's find the zeros of this function over here. And as one gets that way, this is just a random thing I made up. This isn't, these two aren't correlated, okay? Here, how would I get rid of this so there's no more confusion, okay? So let's find the zeros, okay? So if we have a negative 3, that's positive 3. We have positive 4, it's negative 4. Positive 2, it's negative 2. Positive 5, negative 5. And, okay, so let's find what the interval is between the zeros negative 2 and 3, okay? So, what value can we plug in? Well, let's just do an easy one, 0, okay? So we know, if we were to plug 0 into x minus 3, we would just get negative 3. So an easy way to do this is just to keep track of the negative and positive signs and not actually keep track of the numbers, especially when you have 0, because you just write whatever the sign is, okay? So if we're plugging a 0, then we know for the first one it's going to be a negative sign, for the second one it's going to be a positive sign, for the third one positive sign, fourth one positive sign, okay? So if we were to multiply a negative times a positive times a positive times a positive, it's going to be a negative, right? Because there's no other negative to cancel it out. So we know that the interval between negative 2 and 3 is going to be negative. So if you want more examples or more practice with that, go check out Khan Academy, and they'll provide plenty of examples where you can practice that. Okay, so now let's finally talk about end behavior, okay? So what's end behavior? Well, it's exactly what it sounds. It's how a graph behaves at the end, okay? Or as it approaches infinity, okay? So let's work with a quadratic, okay? So quadratics are normally in the form y is equal to ax squared plus bx plus c, as you guys know. As we know, if a is positive, we know that it might form something like that, okay, like a little bowl, okay? And if a is negative, less than 0, then we know that's going to kind of form an upside down, like an umbrella, upside down bowl, I guess, umbrella, whatever you want to call it. So now, let's go on to third degree polynomials. So they're going to be in the form y is equal to ax cubed plus bx squared plus cx plus. So when a is positive, it might form something like that, and when a is negative, the inverse is going to happen. So it might look something like that, okay? Something like that. And just a little thing, to help you draw graphs easier, like, okay, well, how do you know it's going to look something like that? Is because for the degree of the polynomial, it's going to have one less humps. I like to call it that because look, we just have 1, 2, right? Because it's 3, it's gonna be 1 less. 1, 2, right? And for a second degree polynomial, it's gonna be just 1, right? Just 1. That's just an easy way to think about it when you're creating graphs. Now let's do one with how about a 4th degree polynomial? So how about ax to the 4th plus bx to the 3rd plus cx squared plus dx plus f, because we don't want to be using e. So how would that look? Well, let's see. So as a is positive, as it approaches positive values, it's going to be positive, and remember, when it's squared, it's to an even exponent, so we know that it doesn't matter if it's a positive or negative number, so we know that's going to be facing up both ways. So it's going to have something like that and that. Okay, well, because the 4th degree polynomial, it's going to have different humps. So instead of just 1 hump, it should have 3. So it might be something like that, like a W looking thing, because we got 1, 2, 3. Oh, that was bad. 1. And if A is negative, then we know that it's going to be facing down. So we know it's end behavior, it's going to be going negative, right? So we know it's going to look something like that. Just upside down W. Oh, shoot, that was bad here. Upside down. Oh my gosh. We know it's going to be looking something like that. Okay? So we got 1, 2, 3. And okay, one more. You guys might be kind of just like, okay, duh, what does that mean? Well, let me do one more, okay? So how about we have ax to the 5th and, you know, all the rest of that. So what would this look like? What happens if a is positive? Well, because it's an odd number, we know that as it's when it's negative, it's going to be a really negative number. When it's positive, it's going to be a really positive number. So it's going to look something like that. So maybe 1, 2, 3, 4, like that. Okay. And when a is negative, it's going to look kind of the opposite. So maybe like 1, 2, 3, 4. So based off this, what we can conclude is that when it's a even degree, when the polynomial is to an even degree, it's going to be both ends are going to be going to the same infinity, right? They're going to, for when a is positive, it's going to be approaching positive infinity, and when a is negative, it's going to be approaching negative infinity, as we can see with the x squared and the x to the 4th, right? Just with a few more humps, right, in the way. And to polynomials with odd degrees, it's going to be kind of the opposite. So, for when x is greater than 0, as x approaches negative infinity, y approaches negative infinity, and as x approaches positive infinity, y approaches positive infinity, and it's the opposite for when it's negative, right? So, you know, I hope this is helpful. If you want to learn a little bit more about end behavior, you know, check out Khan Academy, where they have a few videos on this. Hey guys, thanks for watching. So today we talked about, you know, polynomial behavioral graphs. So we talked about the zeros and how to find them using factoring. We talked about multiplicity, what that is, how to find positive and negative intervals of graphs, and finally end behavior. So next video we'll be talking about exponents and radicals. I hope you guys learned something. You know, check out Khan Academy, and peace.